speaker today, it's a real pleasure to welcome Katherine Brading back to Western Ontario. I discovered earlier that she's given a talk here before. She is the William J. and Dorothy K. O'Neill Collegiate Professor of Philosophy at Notre Dame, and she has worked on a variety of topics in philosophy, including symmetries in physics, issues in the general philosophy of science regarding structuralism, and also on 17th century natural philosophy. And that, I think, is the original inspiration for the talk today. And one more announcement before I turn things over to Katherine. Our next talk in the series will be November 18th. Alison Wiley of the University of Washington will be joining us to give a talk on the plurality of pluralisms. So today we have Katherine Brading talking on unity, change, and what there is.
Thank you very much. I'm very happy to be back here, and thank you for inviting me. So let's get started straight away then. Alright, so here are two premises now.
Can you speak up just a little bit or have to
How's that? Is that better?
Way better. Yeah.
Way better. Okay, good. So here are two premises up on the slide and also on your handout. P1. All and only things that exist now are real. This is a version of so-called presentism. It says that what is real is what exists right now. This is what there is. Things in the past aren't real. They don't exist anymore. Things in the future aren't real. They don't exist yet. What there is what is present. So now here is bearing a lot of ontological weight. And what about the second premise then? That says special relativity is a complete account of spatio-temporal structure. So this says that there are no good reasons for adding anything to the account of space and time found in Einstein's special theory of relativity. It's complete. Now the problem for people attracted to presentism is that P2 seems to be incompatible with P1, for reasons that I'll come back to in a minute. The dominant view amongst philosophers of physics is that we should therefore reject P1 and adopt a so-called block universe. A four-dimensional structure where everything that has ever existed and ever will exist is all equally real. There is no now of any ontological significance. There's just the whole four-dimensional shebang. That's what there is. Now, being a philosopher of physics myself, this block universe is the default position. It's the kind of, well, yeah, of course, point of view, according to which anyone who's a presentist just hasn't learned the hard-won lessons of physics. So that's just the end of the story. That's where we are. So there I am, and I'm taking this block universe view for granted and working away on something else in philosophy of physics. And I come to realise that the road that I'm going down is taking me back towards presentism, or at least to a position where the dispute between presentists and block universe people becomes an open empirical question, something that hasn't been decided yet. Even if you endorse P2, there's a form of presentism that remains a live option. And that was a bit of a surprise to me, to put it mildly. So at the end of my talk, I'll say a bit about what this version of presentism looks like. But what I really want to talk about is the story of how I ended up with this conclusion. So how is it that a kind of hard-nosed philosopher of physics like me could suddenly find herself endorsing presentism? And most of this story then is about unity and change, and a proposal that arises from within Newton's physics. And this is the main body of my talk. But before we get to that, I want to say a bit more about P1 and P2, so that I can make the link between this stuff about presentism and the discussion of unity and change in Newton. Alright, so back to these two premises then. Let's try to understand why they don't work very well together. So according to Howard Stein, and this is in a 1968 paper where he's responding to Putnam's paper the year before on special relativity. If you adopt both P1 and P2, you get this, and I quote, the interesting result that special relativity implies a peculiarly extreme but pluralistic form of solipsism. Well, why is that? It's a simple argument, and it's one that's familiar from the literature on space and time. So given an event E1 in space-time, E1 is now relative to itself, but there's nothing within the structure of special relativistic space-time that determines which events spatio-temporally distant from E1 are also now relative to E1. So there's no preferred way of joining the dots on here, if you like. and saying that these two events are both now. Okay, just to spell this out a little bit more, you could conclude this directly from conventionality of simultaneity, in which case any joining of the dots in planes of simultaneity is an addition, going beyond the content of special relativity. Or you can get there via relativity of simultaneity, so adopt the Einstein synchrony convention. Note that different planes of simultaneity make different determinations of which events are now relative to E1 and which are not. Note that picking any one of these, a preferred plane of simultaneity, goes beyond the content of special relativity, and so conclude that no other events are determined now with respect to E1. So either way, the conclusion you get is that there's no preferred way here to join the dots. So if we focus our attention on P2 and ignore P1, this argument typically leads to endorsing the block universe. What special relativity gives us is just the entire set of events arranged in a four-dimensional block. But if we want to have P1 as well as P2, we get a different conclusion. If no other events are determinately now with respect to E1, then by P1, no other events are determinately real with respect to E1 either. Add to that the claim that everything that is real must be determinately so, and we get our conclusion. Nothing is real with respect to E1 except E1 itself, hence the extreme solipsism, although each event is real with respect to itself, hence the pluralism. So that's Stein's pluralistic extreme solipsism. That's what you get if you hang on to presentism expressed in P1 and P2. And so far as I know, the view hasn't adopted many adherents, and that's probably not very surprising. Instead, we're familiar with the standard moves in the interpretation of special relativity. You either reject P1 or you reject P2. So here's a little caricature of what this debate looks like. And this is going to be grossly oversimplified. So there are those then who suggest that taking our experience of time seriously requires us to reject or supplement special relativity. So we accept P1, and in an effort to avoid the slide towards extreme solipsism, we reject P2. Perhaps trying to stay as close as possible to special relativity, but adding some kind of preferred foliation so that we get a unique global now. On the other hand, there are those who suggest that taking special relativity seriously requires us to give up presentism, so endorse P2 and straightforwardly reject throughout P1. We adopt the four-dimensional block universe. And we characterize our presentist opponents as intellectual cowards, clinging to their unfounded pre-critical intuitions in the face of overwhelming evidence from the conceptual developments wrought by science. So there are lots of variations, lots of ways of trying to finesse these things, but those are the basic moves. And then I drew both of the preferred foliation and the extreme solipsism as slides because I don't think either of them will do. But the view I'm going to describe at the end of my talk isn't over on this side either. It's not the block universe picture either. So I am going to offer a version of presentism. But what I'm not going to do is argue for it on the basis of our experience of time. I'm going to argue for it from within physics itself. So just to stress this point a bit. I don't think there is some everyday concept of time that we can make use of philosophically and that's independent of the scientific concept. Science starts from everyday experience and investigates those very concepts, clarifying and changing them along the way. I think Rob DeSalle makes this point very beautifully in his book. It's just one quote. So the story in his book is about the engagement of physics with our concept of space and time, the way that developments in physics have brought about developments in those very concepts, and how there's no other concept of time that's independent of these developments and somehow left standing untouched by them. So I'm going to endorse P2. Special relativity gives us a complete account of spatio-temporal structure. There's going to be no adding of a preferred foliation or anything like that. I think that's entirely misguided. Instead, what we need to do is investigate the conceptual development that has taken place with philosophy and physics working together, hand in hand, and if we do that, we'll see that there is a presentist alternative available. So the upshot's not going to be pluralistic extreme solipsism. And the reason why I reject that view is not kind of a simple distaste reaction, but because there's an assumption that's in the interpretation of special relativity that's common to both the block universe person and the presentist person, the positions characterized here. And this is an assumption that I think that the presentist should reject. So this is rejecting this kind of common shared point, and that I think will enable us to move forwards to the view that I want to describe at the end of this talk. So let's get to the heart of the matter then. So the reason why pluralistic extreme solipsism follows from adopting P1 and P2 is that space-time is being used by both of these groups of people, the block universalists and the presentists, as a principle of ontological unity. This is the shared assumption that I want us to reject. That's the claim. Space-time is being used as a principle of ontological unity. And what on earth does that mean? So one thing it means is this. Space-time is being used as a principle of unity for the world as a whole. So here's David Lewis in On the Plurality of Worlds, and this is a quote. Things a world makes if and only if they are spatio-temporally related. The world is unified then by the spatio-temporal interrelation of its parts. There are no spatio-temporal relations across the boundary between one world and another. But no matter how we draw a boundary within a world, there will be spatio-temporal relations across it. So space and time provide the framework within which everything that is material exists. And space-time is the ground of the unity of the world. What makes this material universe one universe is the shared space and time framework within which matter is located. So for those of us interested in modern science, this approach to the unity of the world has a venerable pedigree. Right? In Newton's physics, space and time can be understood as playing just such a role. In Newton's Principia, absolute space and absolute time are the framework within which all material bodies exist. And if we turn our attention to Newton's manuscript, De Gravitatione, we can flesh out the picture. So here space and time are emanations of God, within which the material universe is created by means of impressing regions of space with impenetrability and other conditions. Every created being is somewhere in space and is created at some time. In Newton's physics, God and then space and time are the metaphysical grounds of the unity of the universe as a whole. So now go back to P1. P1 attempts to ground the unity of what exists, what is real, in simultaneity. All and only things that exist now are real. If the now of a given real thing extends to other things, then those other things are also real. The unity of the real is grounded in their simultaneity. That's okay if there's absolute simultaneity. But if now is not spatially extended, then what is real, given P1, is not spatially extended either. And as we already talked about, special relativity doesn't underwrite a spatial extension of now by absolute simultaneity. So given a commitment to special relativity, as asserted by P2, we arrive at pluralistic extreme solipsism. What's gone wrong here is that we bought into the proposal that space-time is the ontological ground of the unity of what there is. And it's not. Or at least we don't have to use space-time to play that role. If we go back to Newton again, we can find two other candidates for a principle of unity. That's what I'm going to come to next. But just to pause for a second, first to say where we are. I've tried to bring out a shared commitment of the presentist and the block universe person to the role of spatio-temporal structure in grounding the unity of what there is. I've also mentioned that this role of spatio-temporal structure is found in Newton's physics, so this is supposed to be, we've got ourselves as far as step 1 on the handout that I gave to you. And then step 2 is going to be to offer an alternative principle of unity, one which is also found in Newton's work. And so that's what I want to go on to now, so step 2. So, as it happens, in fact, there are two other candidates for a principle of unity beyond the space and time one that you can find in Newton's work. So I'll talk about the second one briefly first, and then the third one is the one that I want to concentrate on. So, of these further alternatives, the first attempts to ground unity in the specific forces holding between bodies. It's the forces that appear on the left-hand side of Newton's laws, that kind of glue, on the left-hand side of Newton's second law, that glue the bodies together into one world. So it's this kind of glue of the specific forces that not only physically holds the world together, but also in some sense metaphysically. So the material world is stuck together and is genuinely one by means of these forces. Newton's law of universal gravitation ensures that every material body interacts with every other material body. So adopting universal gravitation as a metaphysical principle of unity we say that the material world is one in virtue of the gravitational interactions among its parts. This approach has some serious problems, and I don't want to spend any time on it now, but it's worth mentioning it because it gets picked up by philosophers after Newton. So we can talk some more about this approach later if you like, but I want to put it to one side for purposes today. So I want to get straight on to the third approach that I want to talk about. And this one, as far as I know, was not picked up by Newton's immediate philosophical successors. And it was because of thinking about this third approach to unity that I got caught up in debates about presentism. Okay, so what is this third approach? To get to that, I need to back up just a little bit and to go to the beginning of where my kind of personal story stands. So the question that I was interested in is this. So what are the bodies that are subject matter of Newton's laws? And what are the bodies that are subject matter of Descartes' laws? So in either case, these laws seem to talk about bodies. So what are these bodies? So there's nothing in here that's obviously to do with presentism or space and time or anything like that. And this was my starting point. And so what I want to do now in this talk today is to show how thinking about this question leads to an alternative proposal for a principle of unity. So this is, as I said, this is step 2 in your handout. So there's Newton, and he's thinking about Descartes' laws of nature, which seem to be all about bodies, and he's wondering what these bodies are. So here are his laws. And he's thinking about this and saying, so what are these bodies that are the subject matter of Descartes' laws? What if these laws are going to say anything, right? And they have to be bodies for the laws to apply to. So what does Descartes say when he says that bodies are parts of matter, and matter is just extension? So how is Descartes' indefinite extension divided into parts such that we can clearly and distinctly perceive that it is so divided into bodies? Immediately before his statement of his laws, Descartes says that motion is the principle that divides matter into parts, whilst also defining motion by appeal to the parts of matter. So there's this pretty tight circle here in Descartes' account, is well known. So it seems as though what we have is laws that refer to bodies, but it's not clear that we have yet a completed account of bodies. So this is a well-known problem, as I said, and there are different ways that you can go. One thing you might try to do is to add some more steps so that you get a completed metaphysical account of bodies before you state the laws. So you try and complete the account, add some more things in order to be able to say what bodies are before you then go on to specify the laws that are going to be about these bodies. The other thing that you could do is to say that the laws themselves contribute to your account of what bodies are. So we don't have a complete account prior to stating the laws. The laws themselves play a constitutive role. And this is the law constitutive approach that I've talked about before, and it's one that I think Newton himself took. So Newton didn't like Descartes' account of bodies for lots of reasons. But the important point for our purposes is that he offers this alternative account of bodies that makes use of the laws. So here are a couple of quotations from his writings. So from the manuscript De Gravitatione, bodies are determined quantities of extension that are mobile and impenetrable such that they reflect off one another in accord with certain laws, they're sensible and movable by us. And then, so that's pre-Principia, then post-Principia. Body I called everything tangible, in which there is resistance to tangible things, and whose resistance, if it is great enough, can be perceived. In their motions, observe the laws of bodies. So I'm not going to make a case for Newton's law constitutive approach here, something that I do elsewhere. These quotations give you a flavour of what he says, and the inclusion of the laws is completely deliberate, and the point is this. It's not that you have physical bodies, and then you ask, what are the laws that they satisfy? No, the laws themselves play a role in constituting the very things that are their subject matter. So of course you can have a weak version where they just make a contribution, or you can say that the laws are both necessary and sufficient for constituting bodies. Well, that's all very well, but how does this provide a principle of unity? And that's the thing that I want to spend the time on in the middle part of my talk today. So let's go back to Descartes again, and his laws. So think about them then from this law constitutive perspective. The first two laws tell us of a single body what that thing will do when it doesn't interact with other things. It will stay in the same state. If we know what properties specify the state of the thing, we know necessary, sufficient, or the strong version, conditions for what it is for that thing to remain the same thing over time. One of the relevant properties, according to Descartes, is the total quantity of motion of that thing. That quantity is conserved, and this is partially constitutive of what it is to be a body. From the law constitutive perspective, the constitution of the thing as a genuine entity, as a unity, involves this conservation of motion. So I'm going to move on and then I'll come back and go over this point again. So look at the third law now. So what's the role of that? Well, the role of the third law is to extend the account from the single things to composite systems. So take a pair of things, have them collide, the total quantity of motion for the composite system will be conserved. We know it's a composite because we start with two things, and we know it's a whole because the composite satisfies the conservation law. If we adopt the law constitutive approach, then satisfaction of the third law is partially constitutive of what it is to be a composite whole. The third law is giving us a principle of unity, in virtue of which the composite is a genuine whole. So again, let me go just a little bit further, and then I'll go back over this again. So as well as having conservation of motion for the composite whole, Descartes tries to give rules for determining the motion of the component parts of the whole. Viewed from a law constitutive perspective, we're being offered a necessary condition for something to be a component of a composite system. It must move according to the third law and the rules of collision. And then one final point, just to get everything on the table. If the laws determine the behaviour of the components, then they determine two things. First of all, the changes that a thing undergoes when it's interacting with other bodies. And secondly, giving the conditions for that thing to remain the very same thing. So as it turns out, Descartes' third law and rules of collision don't work for solving the problem of collisions, but the basic strategy is clear. And this one was picked up, I think, by Newton. So here's the key message then. First of all, in Descartes' work, we have available a criterion for answering the metaphysical question in virtue of what is a given entity of genuine unity. For isolated things, including composite things, the answer is in virtue of possessing a constant total quantity of motion. Secondly, we also have available an account of change. The laws specify what it is for a genuine unity to stay in the same state, and also what it is for that unity to undergo change. Okay, so that's what I want to play. I want to squeeze an awful lot in. My plan is to try and make this clearer by going through the same issues in Newton's physics now. So I want to go back over the same things, but this time in Newton, in the hope that in this process, at the end, things will be clear. So we've got this Cartesian background in mind. Let's move on to Newton, and here are Newton's laws. So let's start again with the case of simple things not interacting with any other things. And consider, first of all, this first law, and think about it from the law constitutive perspective. What this says then is that part of what it is to be an isolated thing is for it to conserve the quantity and direction of its motion. And then laws 2 and 3 extend the first law to composite systems. So if we have a composite system not interacting with any other things, then it will behave just like the simple things of law 1. It will conserve its total quantity and direction of motion. From the law constitutive perspective, we say that what it is for that composite to be a genuine whole is that it conserves the total quantity and direction of its motion. In both cases, the conservation law is providing a principle of unity for the whole. To be a physical thing, be it simple or composite, is in part to satisfy the law of conservation of motion. Newton's general strategy towards composite systems is exactly that found in Descartes. We proceed by construction from the behaviour of a single isolated thing to the behaviour of composite systems via conservation laws. But whereas Descartes failed to solve the problem of collisions, Newton succeeded. And the important point there for our purposes is that the law constitutive approach has now been successfully extended to the component parts of composite systems. So, for example, think about a collision between two billiard balls. Not only is the total quantity of motion conserved, so the composite is a genuine unity, but that quantity is redistributed determinately. And from the law constitutive perspective, This is what makes the billiard balls themselves genuine unities throughout the process. The unity of the whole and the unity of each part is grounded in the laws. So this is a law-constitutive approach to the problem of unity. You can argue about whether or not it's successful. My point is that it's there in Newton's physics, available as an option for a principle of unity, and it ought to be on the table as something we can discuss and evaluate. So this completes step 2 in the argument. We claim that space-time is not the only candidate for a principle of unity in physics. This law-constitutive approach also offers a principle of unity. That's as far as we said step 1, we've had step 1, we've had step 2. Now step 3 is going to be the claim that the law-constitutive approach to unity also gives us an account of change, and that this account of change favours presentism. So this is going to begin to take us back to the stuff that I talked about at the beginning. So here's the law-constitutive approach to change. Change is in the state of a component as determined by the laws. So the laws provide an account of what it is for a genuine unity of the part, in this case, to undergo change whilst remaining the very same thing. Let me say the same thing in another way. The laws provide an account of what it is for a unity to persist through change. That is, to retain its numerical identity whilst not its qualitative identity. And it does this without appeal to either essential properties or to hexaeties. It offers an alternative account, and one which I'm going to argue favours presentism. So let's see how that goes. So what is it then for an object to persist through change? So the prima facie puzzle here is as old as it is familiar. How can a thing, by which we mean a genuine unity, remain the very same thing and yet undergo change? In particular, if f and g are inconsistent properties, so for example being 5 inches long and 7 inches long, then these three things, 1, 2 and 3, f a, g, b and a equals b, these three things cannot all be true. So it certainly can't be both 5 inches and 7 inches long. So how might one respond to this? On the one hand, one might hold fast to the principle that no genuine unity can have inconsistent properties, and then conclude, therefore, that no genuine unity in fact persists through change at all. No numerical identity without qualitative identity. Thus, we make the distinction between enduring unities and perduring unities, and insist that objects persist in virtue of perduring through a succession of momentary genuine unities appropriately related to one another, not in virtue of enduring. On the other hand, we might take seriously the idea that time is doing some important work here, and allow that while a genuine unity cannot have inconsistent properties at any one time, having inconsistent properties at different times might be tolerated somehow, in a way that's to be explicitly specified. So, we allow for the possibility of numerical identity in the absence of qualitative identity, and then since numerical identity cannot be grounded in qualitative identity on this route, we have to ground it in something else. And if we take this road, then there are going to be two prominent options. So on the one hand, one might restrict the class of properties that are required to remain the same in order for the numerical identity of the thing to be preserved. So the essential properties do not change. No object has associated with it a set of inconsistent essential properties, not even over time. As for the accidental properties, we require that these are consistent at any one time, but we don't care whether they can contain inconsistencies over time. Alternatively, we might claim that numerical identity over time is independent of sameness of properties over time. So we appeal to hexaeties to ground numerical identity over time. We don't care about any inconsistencies in properties over time, although we continue to require that some objects' properties at any one time are consistent. So this allows for genuine unities which persist in virtue of enduring. Now, there are good reasons for philosophers of physics to be sceptical about both essentialism and hexaetism, which appears to leave us with no numerical identity without qualitative identity as a feature of our account of unity, and consequently perdurantism as our account of change as the only option. But the law-constitutive approach offers us an alternative. The law-constitutive approach offers the principle of unity in virtue of which a thing remains the very same thing over time and through change of properties. It does so not by appeal to exeities, nor by appeal to essential properties, but by specifying the relations that must hold between the states of a thing at different times. Now you might think, okay, but this view is compatible with both perdurantism and endurantism. For the perdurantist, the laws specify the relationship between successive momentary genuine unities, whereas for the endurantist, the laws specify the relationship between successive states of a single genuine unity. But this isn't right. Here's the crucial question. What are the perdurantist's momentary genuine unities that are supposedly tied together by the laws? In virtue of what are these, the things that are tied together, themselves genuine unities? If the genuine unity is grounded in qualitative identity, give me an argument why I should accept this view. If it's grounded in something else, tell me what. So I think that the law-constitutive approach gives us an argument in favour of endurantism as against perdurantism, because, according to the law-constitutive person, the very principle that grounds the unity of a thing has as one of its consequences rules by which such a unity can undergo qualitative change. So I want to press on this key point just a little more. In generating the prima facie puzzle about change, we had to write down A equals B. But in order to write this down, we have to presuppose that our things, labelled A and B, are genuine unities. And we need an account of what grounds that unity. We can't take unity as brute, at least not without saying why the worries of 17th century philosophers were misplaced. So in the absence of a principle of unity suitably argued for, the perdurantist is at a disadvantage compared to the endurantist. The law-constitutive approach offers a principle of unity which provides numerical identity without qualitative identity, and it provides an account of what it is for a genuine unity to undergo change. It's an approach that arose with an attempt to construct a physics and a metaphysics of things by two giants of this enterprise, Descartes and Newton. What it gives us is a reason to prefer endurantism. Okay, so now then, well, it's true that both endurantism and perdurantism are compatible with both presentism and four-dimensionalism. But most metaphysicians think there's a more natural fit between endurantism and presentism, and between perdurantism and four-dimensionalism. If that's right, then the law-constitutive approach to unity and change favours presentism. So this is the end of step 3 of the argument that I wanted to take you through. And as I said way back at the beginning of my talk, this conclusion was a bit of a surprise to me. Where it leaves us is with a tension. On the one hand, considerations arising out of space-time theory push strongly towards the block universe. On the other hand, in thinking about Newton's physics, I'm being pushed towards a version of presentism. So the last part of my talk is going to be about getting rid of this tension. And this is what's going to take us back to P1 and P2, and presentism and all that from the very beginning of my talk. So this is the last step, step 4 on the handout, and it's the last part of what I want to say today. So the thing that I want to ask you to hold on to is this. You have two options arising out of Newton's physics for an ontological principle of unity. This is if we ignore the one that appeals to forces, I think, right? So one is the law-constitutive approach, and the other is space and time. And we don't need both, right? We only need one, we don't need both. So let's just suppose then that we take a law-constitutive approach and see where it takes us. What happens to presentism then? Well, let's think about the status of space and time first. We don't need them as a principle of ontological unity anymore. So what role do they play? Why do we set out a big arena of space and time when we're doing physics? In mechanics, we want to know what the outcome of a collision will be before it happens, based on knowledge of events prior to the collision. Quite generally, one thing we're doing is trying to extend our knowledge of events to times and places distant from the here and now. Space and time play a theoretical role, as we try to extend our epistemic reach beyond the here and now, stitching our predictions together into a single whole. Thinking of things in this way, space and time provide an epistemic principle of unity. They provide the framework in which we organise our knowledge of the not here and or not now. So there's no necessary inference then from this epistemic role for space-time to the view that space-time is an ontological principle of unity. If we go this route, then we have to revise our understanding of P2. We can be committed to special relativity as a complete account of spatio-temporal structure, but we recognise its epistemic status and don't make any direct inference from that to any ontological commitments. Whatever spatio-temporal ontological commitments we have must come from paying attention to the details of the dynamical laws of matter. Matter is spatio-temporal, but it's not in space and time in the sense that space and time provide an ontological principle of unity for what there is. We need to think about it differently. The dynamics ground the unity of a thing, and the spatio-temporal extent of that thing is whatever size it needs to be in order to sustain the dynamically characterized thing in question. So P2 now means two things. First of all, we take special relativity seriously as an epistemic principle of unity. This is the best way of organising our knowledge that reaches beyond the here and now. Secondly, ontologically, what there is grounded in the dynamical laws, and these include the spatio-temporal characteristics of things. If things are spatio-temporally extended, then special relativity tells us that within that space-time region there are no purely spatial or purely temporal relations. Things occupy time just as they occupy space, by existing as a unity that's spatio-temporally extended. The spatio-temporal extent of the sufficient dynamical ground of a given unity might turn out to be much, much smaller than the abstract spatio-temporal structure within which the evolution of that unity is completely described. This is an empirical matter, something to be settled by the progress of science. So what becomes of presentism? This view is P1. And clearly we need to rewrite it. We're not going to start from Minkowski space-time when we do ontology, and so we're not going to be driven by our considerations of the structure of Minkowski space-time to the conclusion that the present is merely a point in Minkowski space-time, and that therefore this is all that is real. We're not going to use a now derived from the structure of Minkowski space-time to ground what is real. So we're not going to end up going down the slope to pluralistic extreme solipsism. Presentists shouldn't use now as the grounds of what is real. She should use dynamics instead. The present is a spatio-temporal region of whatever size is necessary to sustain the dynamical system in question. It might turn out that this is the entire history of all the universe, encompassing everything that ever has been and ever will be. The only dynamical system that there is this entirety. There are no genuine subsystems of the universe. If that turns out to be the case, then the presentist is defeated and the block universe person wins. But notice that this is now an empirical matter, something to be decided by consideration of the details of physics and perhaps science more generally. So let's begin then from the position that there are in fact genuine subsystems. This means that the size of the spatio-temporal region required to sustain the system is less than the entire block universe, and so the present is, at least in the first instance, local, not global. This local now does not lead to solipsism though, because it's not the ground of what is real. The ground of what is real is the dynamics, and we belong to the same world as whatever we interact with, and the rest of that world is as real as we are. The dynamics grounds the unity of what there is, both of the parts and of the whole, consisting of interacting parts. And this is what prevents the presentist from becoming a solipsist. So does my son exist relative to me when he's in South Bay right here? Well, of course, there are plenty of interactions going on that link us. Is there a determinate fact of the matter about what he's doing right now? No. There's a lot of work to be done in filling out exactly what this position says. That's to put it mildly. But one thing we can do straight away is to reformulate presentism such that it doesn't ground the reality of what exists in space and time. So here's what's maybe a further attempt. For each and everything, that thing exists only presently. The spatio-temporal extent of that present is dependent on dynamics and is something to be determined empirically. So there you have it, that's step 4, a revision of P1, a revision of what we mean by P2. The upshot is an overall package containing a version of presentism that endorses P2. And now all I have left, before we can talk or discussion, is just some final remarks. So, that we can systematize things into a global spatiotemporal framework is surely an interesting fact. And you might want to ontologize the overall framework above and beyond the dynamics. You can if you want to. My point has been you don't have to. And if you're going to, you need to say why adopting space-time as the ground of ontological unity is better than using the dynamical laws. The most interesting thing about this for me, as you may well have gathered, is that this approach renders presentism an empirical thesis. A great deal rests on whether there are genuine subsystems of the universe, and that's something we can find out only through empirical inquiry, and with philosophy and science working hand in hand together. So that's the conclusion of my argument. And as for the conclusion of the personal story that's been running through this talk, it would be far too strong to say that I'm a presentist. What I should really say is that, to my surprise, there's a version of presentism that turns out to be an empirical thesis and that's consistent with endorsing P2. It's probably not a version that any of my metaphysical colleagues in my own department would recognise, but I think it's one, probably perhaps the only one that's available if you take physics seriously. It's also one that arises naturally from philosophical engagement with the work of Isaac Newton, and it's one that even a self-respecting philosopher of physics like me can feel comfortable exploring. Thank you.
So, just for clarification, I wasn't sure if the remark that you quoted from David Lewis was really quite opposite. I thought, in a sense, isn't he talking about something else? There's a kind of Kantian idea that what makes for the unity of the world, as a single world, is the presence of things to one another in a spatio-temporal framework, which really isn't concerned with the question of the unity of the thing through time. Right? That could be considered a kind of empirical question within the spatio-temporal realm with respect to which everything is sort of present to everything else. And the second thing I'd like to ask is, isn't it, the idea of law constitutive accounts of things makes a lot of sense to me, but dynamical laws of the kind you're talking about, at least, all sort of classical non-quantum ones, make presuppositions about the structure of space and time. That makes it impossible to say that I'm giving an ontological account through dynamics that's different from the one that I would give through space and time, because these dynamical laws that I'm presupposing bring with them a lot of presuppositions about space and time. And if that were the case, wouldn't it be possible for me to reformulate your argument like this? Right? In the Newtonian case, there are dynamical laws in virtue of which I can talk about the interactions of things, and in which the idea of the present moment, or the now, plays a really fundamental role, because those dynamical laws presuppose an invariant account of simultaneity. Whereas with special relativity, I have a different set of dynamical laws in which I regard the Newtonian extension of simultaneity beyond my own light cone. And I regard that as a kind of global extension that isn't really justified by the physics. Right? So now I'm using dynamical laws that simply don't justify me in talking about a now, except as a purely relative construction of my own perspective. And then I could say, in virtue of this argument, well, yes, it always was an empirical question, whether presentism was possible. It's been answered by special relativity. It wasn't that I began with Minkowski space-time. I began by trying to figure out whether the Newtonian dynamics and its implicit conception of now could be extended globally. Electrodynamics taught me that I can, and the empirical question has been asked and answered.
Yeah, okay, so clearly I'm going to say no. What you just said, I don't really kind of spell out why.
Well, it's a yes or no question, so I guess you've got
I'll do the second question and then come back to the first question. So yeah, that was the short answer. Here's a longer answer. So part of what's going on in this project is to take some inspiration from Newtonian physics, to look at physics, coming at it from philosophical questions that I have and try to think about the development of physics engaged with the history of philosophy to tell this story. So it's not that I think the kind of answer that I'm looking, so the kind of view that I want to use to think about physics is already present and well worked out in Newton's physics. No, it's got far too much. It's got space-time, it's got the laws, it's got interactions as well that get suggested as a possible principle of unity. So there are different ways that you can go, and clearly you can go the space-time route. Part of the motivation from what I want to do is to look at contemporary physics, where I think it's much more up for grabs about where we, what we take to be primary, and whether the space-time structure is derivative or whether it goes in at the beginning, and to look at to think about that by looking at, well, what are the alternatives that are on the table that come out of earlier physics. So it's true that I can't write down my interactions without making spatio-temporal commitments. So what does that really mean? Does that mean that I'm presupposing some spatio-temporal structure? I don't think it's not decided yet about whether through the development of physics we're going to understand that spatio-temporal structure can in fact be derived from other, and put in other degrees of freedom and outcome of spatio-temporal structure. So I don't know whether this is answering. From your frown, I think I'm not answering your question.
Well, I think that there's two different questions. So, whether special relativity, for example, is an adequate account of where space-time comes from, or whether, I take to be Minkowski's argument, by employing the principles developed by Einstein, we are in fact making certain presuppositions about space and time, which are only sort of brought to the surface by the account of Minkowski's space-time. And the same with Newton, right? It's not that I want to know whether space-time is primary or dynamics is primary. It's that I have dynamical laws that in the way that I now articulate them, maybe there's another way, but as articulated, they bring with them certain very powerful assumptions about the relation between space and time and motion.
You need to say more before this becomes. So what then is the challenge to what I want to say?
Well, it's not necessarily a challenge to what you want to say. It's that if you want to acknowledge that I don't really, in the classical setting, I don't really have dynamical laws that don't sort of bring with them a picture of space-time, then the empirical question, should I believe in presentism or not, could be regarded as the same question that's answered by special relativity. Can I extend the Newtonian notion of simultaneity beyond the state of motion of an individual observer, or do I have to regard it?
I would say that they bring with them. So it's true that in order to formulate the things that we want to say. So this, I don't know whether this is what you're asking about, is this move to saying, well, look, the spatio-temporal structure, sure, this comes out of the theory, but what status should we give to it? Now, this might be something that physicists perhaps isn't interested in, but for me, I'm very interested in that. I want to know. So I'm asking the question, what is that? And I want to know about the status of space and time. And nothing in what you've said yet has told me about that. I have different ways that I can go on that. And I could say, right, I'm going to take the spatio-temporal movements that come out of this as being things that I want to say are part of what there is.
Oh,
And I think that has been a route that people have
so
taken.
we have the keep going on about this.
Okay.
I just, all I meant to say was that if I assert something like the law of inertia, I feel that I'm also asserting whatever it presupposes about space.
So I don't like someone wrong. Rob asked most of the questions that I was going to ask him much better than I could have asked them. Let me go back, though, to the introduction of the example of David Lewis, which I thought was a little bit misleading. I mean, maybe you don't agree that it's misleading, and if so, I'd just like to know why. I mean, Lewis does seem to be speaking of the unity of the world, and that does seem to be connected with everything being within a common spatio-temporal framework, whereas your preoccupation is with the unity of a thing, which might more plausibly be reconstructed in accordance with a dynamical principle. But those are clearly different. And somehow orthogonal to one another, because one thinks that different worlds may share the same laws or the same dynamical principles, but that they don't share the same spatio-temporal framework, which I guess is the intuition that underlies Lewis's emphasis on space and time. But do you not see a difference between your concerns about unity, insofar as they are focused on the unity of things, and Lewis's concern, which is the unity of a world, one of which is fairly plausibly understood in terms of a common spatio-temporal framework, and the other is maybe more up for grabs.
So one of the things I'm interested in is the universe as a whole. So that is a thing for me, and perhaps that is the only thing in the end. If there are no subsystems, then the universe as a whole is the only thing. Unless there are other universes, maybe that's very much part of this.
Well, Lewis is talking about unity of worlds. Each world may come with a universe. The other comment that I wanted to make is that the application of your idea to presentism seems to me to choose one animal out of the zoo of metaphysical doctrines, and maybe not the most apposite one for what you're after, because your final resting point for presentism has to do with the possibility of independent subsystems. That is more reminiscent of various forms of philosophical atomism of the kind that motivated people at the beginning of the 20th century in connection with logical atomism and monism, rather than with a thesis about perdurance, endurance, presentism, or any of those doctrines. And it might be, this is just a remark, that it might be something you want to look into as a different way of framing the idea that you want to put forward. Maybe it's an alternative to presentism, and that will fade.
So first off, thanks very much. That was rich and stimulating and promising. And of course, there's a but. The but is, I don't think that your solution, however promising, can be a general approach to ontological unity and change, because at best it only applies to material things that move around and bump into each other according to physical laws. And I think there's lots of other things which have unities and undergo change that are like that. So, a bunch of examples. O Canada, our national anthem, the U.S. Constitution, the phone to an after image when I poke my eye and then take my finger off it. I love the one you just mentioned, actually, the universe as a whole. The euro, the forward focus, that is the model, the larger point that I think this relates to is, I wouldn't think that special relativity should be our sole guide to what there is. And maybe the philosophical folks that we resisted at the very beginning are actually on this thoughts.
So the last thing, just elaborate on the last thing, and then I'll come back to the first thing you said. So what was the...
So the last thing is that maybe special relativity shouldn't be our guide to what there is, the sole guide to what there is.
Okay, so...
Because there seem to be lots of things like IBM and U.S. Constitution and after
That's how it
years.
relates to the first thing. So there's a general question here about, how we populate our ontology, and I'm certainly open to there being. So for myself, I'm very open to there being all kinds of ways of talking about the world that are meaningful, that carve the world up in different ways, and that are useful. And certainly what I'm focusing on here is physics as a way of talking about the world and what kinds of commitments we should have if we're going to say that the physics is about the world. So what is it about, and how? So what is the subject matter of physics? So I am completely happy to say, this is a narrow project in that sense. This is about, if you take physics to be a way of talking successfully about the world, then what is its subject matter? How does it come to talk about those things, and what in fact does it say? And so this is I don't. Maybe there's something you want to say back to me about why this is not okay and this is not enough, or why what I'm doing then is problematic.
Well, I thought you were after bigger game, which is understanding unity through change.
Mm-hmm.
So my thought was just that at best, the story you're telling can give us a handle on unity and change in a certain subpart of what there is, but it can't do it it can't be a general account.
Well, it depends whether you think that then in these other domains, how those domains get their subject matter, and what's going to count as change for them. So if you take a more general, so the kind of approach that I'm taking, if you generalize it, is the kind of implicit definition approach. So if you're going to construct the subject matter of the theory through implicit definition, then this is going to generalize across other subject matters in that way.
That's helpful.
In the suggestion you're making at the end, that you would boil down to an empirical question, there's a phrase that occurred that I want to understand better, which was genuine subsystem of the universe. And can you help me understand with how you're using that phrase? And an example might help. If we stick for the moment to classical physics, and you think of a Newtonian system under the solar system, and that might be a subsystem of the universe, and then the sun might be a subsystem of that, the Earth Moon system might be a subsystem. Are all of these genuine subsystems, or does it depend on whether these things are in fact divisible into, and which there's, whether they're divisible and genuine subsystems is divisible parts?
No. So all of those are. So this kind of flattens the hierarchy, but where it stops is at the level of, say, let's take a two-body system. So take a sun as a planet going around it. Now, say suppose that I'm taking Newtonian mechanics and I'm taking gravitation as my force law, then I have to stop there, because the Earth, if that's our planet, has to be a gravitational simple if there are no other forces involved, otherwise it's just going to collapse on itself. Right? So we're going to have to introduce other forces into our story if that's not going to be our simple. So that's one subsystem, but we can build up as much as we like, as long as these things can appear as bodies that interact with one another and follow the rules.
So in the natural case with gravity plus other forces, then the Earth doesn't have to be a simple. I can think of the Earth as being composed of subsystems,
yeah.
and then the question is about subsystems and the size of the spatio-temporal region required to sustain the system. So is the issue, what is the empirical issue that's being asked? And it's going to be this, tell us whether presentism is right or not, whether there's a smallest subsystem system or what?
No, so suppose I ask about me.
Right.
So I can ask, well, what is the smallest spatio-temporal region that we need to have in order for me to be, to dynamically sustain me such that I'm not just the bits, that I'm actually here. Well, this might be bigger than this spatio-temporal region that's needed to sustain the particles I'm made of. Suppose I'm made of particles. So we have to ask for each subsystem. And so this is going to be something that, so it's not that there's, something, we're not going to get back a shared present. This is part of the story. This is not what's going to come back. It's going to be, the present is going to be something for each system. And then if that system has parts, each of those parts has a present that's proper for that part that depends on the dynamics. And this looks like all horrible and relative, except, but it only starts to look horrible and relative if you're worried about what role that present is playing with respect to the other things. But all of us are tied to one another by the Democratic laws, by being parts. So we don't lose, we're still all tied together into, we don't end up with solipsism.
So again, in the interactions that hold you together take a certain amount of time to act, and so there's a temporal interval below which you can't talk about you.
Yeah.
Okay, I'm going to use my position as chair. So I think the question that I've been steering over is related to Robert's question and Wayne's question. You want to pry apart the sort of dynamical principle of unity and a space-time approach to unity. And one objection is that dynamical laws aren't written on empty air, right? They have presuppositions. And the way you phrased it in trying to prise those two apart is that there's an epistemic versus ontological thing that we should be careful about. And you phrase that in terms of taking assumptions about space and time and extending them beyond the local system you're discussing. But there's also, as Wayne was just emphasizing, it's not that you have a dynamical description of the system that only involves space and time notions when you extend it. In describing the component parts of this, there's implicit in that description and the constraints it imposes on the component parts, space and time, notions of space and time that arise. And so you were just talking about this, but I'm not quite clear. So when you're in the talk saying you want to distinguish between the ontological versus the epistemic notions, it seems you were thinking about the question of extension. But I think even just describing a system and its component parts and so on, there's, in that same sense, a notion of space and time. And that's harder for me to prise these apart. It looks like they're entangled in Newton because they should be entangled, right? The dynamical account and the space-time account are tied together in ways that it's hard for me to see how to pry them apart so that you can...
So I should think hard about how to answer this in a way that's clear. I'll try. I don't think it's going to be very clear, but I'll try. So I don't want to deny, right, that something is a spatio-temporal thing. The question is, how do we understand that? And so it's true that when we write down our theories, we write them down in certain ways. We just make use of a spatio-temporal framework, and then we can write down our dynamics in that context. So the question that you're asking about is, well, how much of that is just, an artifact of how we write them down, and how much of we legitimately say, well, so the spatio-temporal structure is bigger than the thing that we're trying to describe using that framework. And I don't know the answer to that, but I think we should be asking it, and I think it does come up in the context of, just so much is up for grabs in the context of contemporary physics about how to relate space and time to the matter degrees of freedom and things like this. So I'm not going to say anything here, but and I think that's exactly right. And I don't know the answer, but I want to make it a question because I think this question bears on whether there's a viable alternative approach here. But I think that's the best I can do.
So this question, I think, is continues in the vein of questions that have been asked. Let me give you a specific example. So we have in some fairly isolated region of space, we have a charged plasma. At a charged plasma. At one level, if we're making measurements at fairly large spatiotemporal regime, then we can use continuous thermodynamics and classical electromagnetism to model the system very well. As we start making measurements at smaller and smaller spatial temporal intervals, eventually the continuous thermodynamic description is going to break down. We're going to have to start using molecular kinetics, but classical electromagnetism will still work. As we get smaller and smaller, perhaps higher energies, even classical electromagnetism will fail. Now it seems to me how you're going to describe the system, what kind of unity you're going to ascribe to the system depends quite crucially on the level of the spatial and temporal scales that you are worried about, and concomitantly the theory that actually works at that scale. So it's no longer clear to me how exactly your account is independent of at least that kind of, at least the pragmatics of spatiotemporal structure. You have to fix your spatiotemporal scale in order to fix your theory, once that happens, I also lose my grip on why you're talking about ontology and not just something about pragmatics, because it depends entirely on what theory you're using to describe the same system.
So there's lots of things into that, right? So one thing is, look, we have different theories that we use to describe different things. So we have this, patchwork, and we don't at the moment have one theory that we can use to describe everything. Well, yes, and maybe we never will have. So this is about what we can say about what there is, and maybe all that we can say, is always going to, at the moment I don't understand why, so you need to say more to make me understand why this is a particular problem for me. I'm just going to say,
it may not be a problem. It may not be a problem for you. You maybe have to accept it. It seems to me that if you do accept it, then your account no longer seems to be about ontology, but simply a matter about what we can say about the world given the theory that we choose to use to model a given system, which seems to be a very pragmatic matter.
So, on the one hand, I could put on a different hat and say, well, I'm going to resist this and, push towards some kind of realist picture, which in the end there is a unique story that I can tell, and it's only once I get that I'm really doing ontology. But that's not so I could go that way and then, try and spell out this story for this ideal case at the end, but that's not how I think we're doing ontology way before that. And we're saying what can be said about the world, subject to certain, under certain conditions and subject to certain idealizations and considerations, and that's, that is what it is to do physics. So this is a kind of, it mixes in with pragmatics, a pluralistic kind of approach to things, but that I don't think doesn't undermine this at all, because that's how we do ontology, that's the best we can do.
I'm particularly interested in questions from graduate students, since nobody has asked one yet. And there are questions from people who've already had a chance to know.
I won't only ask them if nobody else has one.
Please, somebody.
Your professors are judging you on this. That's what Chris is really saying.
Are there enough questions from the space you'll temporarily remote?
Yeah, how about those guys? No, I think you've done something really interesting, and what I've said so far is really somehow something in the way you framed it sort of mischaracterizes it, but I think it could be characterized again from a kind of neo or crypto Kantian point of view. Because what I think you're starting from is this idea that the ontological implications of special relativity are sort of taken for granted from the beginning. Right? Well, there's this four-dimensional world in which it doesn't come with the decomposition into nouns. Right? Whereas the other ontology starts with now as an ontological notion. But that isn't actually what's happened in physics, right? What's happened in physics is something that I think Kant made some attempt to articulate. We don't really have a remote picture of the structure, the relations of things in space and time, except with the help of physics, right? The peculiar, unique, and philosophically important thing that Newton has done has given us he's given us these dynamical laws in virtue of which we can actually not merely say or imagine, but sort of think, in Kant's strong sense of that term, of the presence of all the things in the world to one another, right? They come under this notion of community through the understanding of them that we get through physics, which they don't otherwise have. So special relativity, however, isn't the theory that just comes along and says, throw that away and accept this block here. It says, ask the dynamical question. Is this extension of our local interactions globally to a global sense of simultaneity, is that really legitimate? Do we have a theory that really does that for us? And the answer to that question is no. Right? And in a sense, this is what I think you've done, except you've characterized it in a different way. It's special relativity's criticism of the standard ontology of presentism isn't just that it has a better ontology that it got from science, right? But it has an understanding of dynamics in virtue of which it's able to show that the extension of one's local idea of now fails. So that's one way, another way of putting what I said before.
What I want to do is more than that, right? Is that I want to say, okay, so when we're trying to understand, to reach beyond ourselves and to understand in what way we're related to other things, to what else there is, and what are those, so what grounds those relations between me and the other things that there are? Is it that I stand in certain spatio-temporal relations to other things, be there now or not, be that as special relativity says, or as somebody thinks is an absolute now says, or is it in virtue of something else? And so what I want to say is, so typically we think about it, well, it's this, so we're all, we're in this spatio-temporal framework, I stand in certain spatio-temporal relations to other things, that's how come we're part of one and the same world, or whatever. And I'll say, well, that's not the only way to go. There is this other, this other way to go that starts that makes the spatio-temporal relations, if there are any derivative, and it makes them derivative on the dynamical relations. And then the challenge comes, well, how do you say what those dynamical relations are without expressing them in spatio-temporal terms? And I think that's, so I don't see that as an objection. I think, well, yeah, I'm going to, that's how we express, that's how we situate things with respect to one another. We found this, there is this beautiful way of making, doing this in a four-dimensional framework, but that doesn't take away from what in the end is doing the work of making you and me in the same world, doing that as the dynamical interactions between us. And so when we're asking about what there is, and about this, the extension of how far I can reach to other physical things, I shouldn't be asking about the spatio-temporal relations. I should be asking first about the dynamical relations between us, about the laws by which we interact with one another. And so, but then you say, well, what about, time and space? When are you? That kind of thing. And I want to kind of resist that and say, well, I have a spatio-temporal extent, and so do you, and so does the system as a whole. That's not what's doing the work in making us related to one another and part of some world.
I have a question. That follows up on that. I'll just be a second.
Okay.
I thought I understood something about, and this is just a question of clarification. I thought I had an insight into what you meant when you said that space and time should be looked at as epistemological rather than ontological principles. Is what you mean something like this? That while
that could be right, yes. So I don't have a positive conclusion, but certainly that is it within the space, yeah. So this goes back to one of the things I said about, reflecting on what is it we're trying. It's not surprising, right, that physics ends up presenting us with a four-dimensional arena in which all these events are located. That's precisely what we're trying to do. We're trying to find out about what happens at places and times distant from us and to organise them in such a way. But that doesn't mean that, so it's sort of a natural product of project of trying to do physics, but then when you want to think about what are those systems that we've located in this arena, we might want to think about that in a different way.
I'm still trying to get clear on what sense we're getting some kind of presentation out of this. And I guess, I wonder if I can understand it with reference to a concept that Howard Stein introduced in his other paper on space number one, where he uses Nicholas Maxwell. Because there he says, okay, sure, we grant that if I take a space-time point, there's no extended present that I can associate with that space-time point. But if you take a spatio-temporally extended region, for example, Katherine Brading saying the word now, even quickly, now it's long enough for my conclusion. See, that's a special, so take that space of temporally expanded region, he'll say an event is contemporaneous with that if a signal can go from the region to that event and back. And if you think, it takes you probably a third of a second to say now. There's plenty of time for like go back and forth to South Bend during that time. So there actually is a matter of fact about which events are contemporaneous in South Bend with you saying that. And Stein's suggestion is that suffices as a spatially extended present for our purposes. And what he's really trying to do is explain why it is that we ever thought there was an infinitely spatially extended present. Anyways, and what you're getting is not a infinitely extended, spatially extended present of a space-time point, but of a set of events which can be a very short duration, in fact, as small as the timescales on which we deal with. There nevertheless can be a spatially extended present of that, which suffices as a precedent. So is that in line with the sort of things that you're suggesting?
Yes and no.
Okay.
So different aspects of it. So one aspect is the so I'll do the yes bit first. So yes, in the sense that what it takes for me to be able to say now is that there has, I have to be a sufficiently complicated and robust system that has a sufficient spatio-temporal extent to be able to utter the term now. So the yes part is yes, but more. But I want to get from the physics what the extent of that now is. I think that physics can do a lot more work for us in fleshing out what that account would look like. So it's not. So the no part is not just about this, relationship of signals and how far away stuff has to be and how quickly the signals can travel between them. So one worry about that is that in the end you end up back with the built universe as we start, reaching very far away. Frown about but so the no part is that because it's not enough yet. What else do you need? What more do you need? Is to ground that. What is that depth? What is that size? Or maybe you don't need to, but you can. So the interesting thing is that it turns out maybe you can turn to whatever different science. It can be not physics, but some science, and ask about what's the size of the spatio-temporal region that's necessary for me to exist to be as a thing.
Wouldn't that relativize one's metaphysics to how quickly people speak, how quickly beings speak?
This is, why I know we have to get into more details of the silence. So, maybe I'd say, I don't know how big I have to be in order to exist spatially temporally. I don't know the answer to that question. But it's an empirical question. What is the duration and size that has to, how long do I have to exist in order to be a person? It takes time for the kinds of processes to happen that are enough to make there to be a person here and not just some collection of smaller things.
First, we can take this on back.
Sorry?
I'd like to speak with you about it after.
I'm trying to get an idea of where some sorts of empirical answers to some parts of the question. And I'm struck by a connection between what you're saying and what I heard Lee Smolin say at Perimeter at a conference on emergence in field theories. And he was trying to defend quantizing gravity as a more fundamental way to go than taking relativity, say, as fundamental. And he kept talking about how the laws themselves change. He talked a little bit about Peirce. But I take it that making room for the possibility of Lee being right is part of what you're trying to do here.
That is not so let's say.
Well, let me give some more, because Lee made a big, he really described the block universe. He said, that's not enough. I need to have this room for real change. Okay, and so that's where I want to see whether you would take that as a friendly question and to just think of what you're doing as simply making room. I mean, there obviously is not nearly enough to settle this either way now. But Lee thought there was. Lee thought it was obvious that it had to be quantum mechanics and not GR. Quantum mechanics that GR had to be quantized. Bradley had to be quantized. But that it should be possible for him to be right is part of the claim that you're making, that we can't just settle with the block universe.
How can she answer your question without having been in this talk?
Because I've given the background enough to see whether, I want to see whether that would be a part of what's...
So what is it? So I'm not sure that there is enough. So
Okay.
What is it that he's trying to allow for? He's trying to allow that
a role of developing. This is, he didn't put it this way, but a more fundamental role for development, for theories that have a developing now kind of framework than is allowed for at GR.
then yes. What he needs is for there to be, for the present to be spatiotemporal more than the entire spatiotemporal extent of everything that there is.
Okay, last call for a question from a graduate student before I arbitrarily pick one of you at random. Please join me in thank you, Katherine.